So we just did an example of surface area and a real-life application. Keep in mind there are many of them. So now let's take a look at volume and surface area. Okay. So specifically I'm going to do an example for volume, and there is an example for surface area included that you can take a look at, but it is pretty much exactly the same as doing any other surface area calculation or the last time we did another area application. So it's very similar, so take a look at it. So first of all, just as review, when a structure or object is made up of several simple objects, okay, we call it a composite shape. Okay? So remember that definition. Composite shape. Shape that's made up of smaller parts. So examples of these in real life, remember composite shapes are everywhere, and there's more of them than just your standard rectangles. Buildings, we have tools, vehicles, blueprints, I mean even furniture is all made up of different smaller shapes all stuck together. So as an example, okay, we've done a lot of area examples, so let's do a volume. So if we need to find the volume of this shape here, okay, so it says a local snow removal company has just purchased a salt and sand spreader for applying salt and sand to parking lots after the snow has been removed. The spreader is a composite figure made up of a rectangular prism on top of a triangular prism. Okay? So you can see we have, that's 8 inches there. Okay, this, if we were to cut it along here and along here, okay, this is a little rectangular prism on top of the triangular prismed base. Okay. So now we're being asked how many cubic yards of sand will fit in the spreader if the overall length of the spreader is 7 feet. So we know this is 7 feet, this width, or this height, sorry, is 32 inches, and that is, I'm not sure if you can read it, that's 50 3/4 inches. 50 3/4 inches. Okay. So step 1 of doing these types of questions is determining your shapes, okay? So draw your shapes. And drawing the shapes will help you because you can actually label each shape with the lengths you know, and that way you can see shapes that you can actually calculate the volume for. So we have a rectangular prism. It's kind of long and thin, and it's kind of sitting on top of our other one. Okay, so we've got a rectangular prism, and then on top or beneath that is our base. Okay. Whoop, didn't do a very good job drawing that. That should go straight back there. Okay. It's our triangular base. Not very well done. So step 2 is to actually calculate the volume. Of the individual shapes. Okay. So taking step 2 into consideration, these ones are much better drawn. Okay. And if yours look like mine, that's fine. Okay. Step 2A, so now we need to include all of our lengths. This is, I think, 84 inches. Yeah, okay, 7 feet is 84 inches. This is 8 inches. And this is, once again, 50 3/4 inches. Now, keep in mind, I switched them all to inches. You could have switched them all to feet as well, and it's not really a big deal which way you go, as long as they're all the same unit. Okay? So you can't have this one in feet, this one in inches, and use those numbers in the same calculation, because your units won't work out. So as long as it's the same, you're good. Okay? So volume, we're going to call this shape 1, okay, would be length times width times height, which is 84 times 8 times 50, and I'm going to use 0.75 instead of the 3/4. Okay, so this one would be 34,104 cubic inches. Or, okay, if you had done your calculation in feet, you should get 19.7 cubic feet. Okay, and this shape, okay, this one is, let's do this one in feet. Okay. This would be 4.2 feet, and that came from, if you take a look at the shape, okay, this across has to be 50.75 inches, so that would be 4.2 feet. This is 32 inches, and that's the same as 2.7 feet. I've got the base, height, and now we need this length here we knew was 7 feet. Okay, so I've kind of done some of the unit conversions automatically just to save time in the video. Okay, but if you want to go through that again, please go back and check out the unit conversion lessons. Okay, so V2, we're going to call this one shape 2. Okay, it's 1/2 the base times the height, which is, the base is 4.2, height is 2.7, and then multiplied by the, multiplied by the 7. Okay. So if we multiply all those out, we get 39.7 cubic feet. Okay. 39.7 cubic feet. So once we have both of those values, okay, step 4 is calculate the total volume. Okay, so V total. So the total volume for this shape is the shape of that small one on top, V1 plus V2. V1 is 19.7 cubic feet, and the triangle on the bottom, triangular prism, is 39.7, which is equal to 59.4 cubic feet. This question was asked in words. Okay, it was a word problem where they gave us a snow removal tool. Okay, so we do have to answer in words. So we could write right here, therefore, okay, 59.4 cubic feet of sand will fit in the spreader which is, and then we're going to need it in cubic yards. So that's how to go through and determine the volume of a composite shape. So break it down into smaller shapes, follow these steps, and you should be able to apply that to pretty much any question. Just remember your unit conversions.